Hello, everyone, and welcome to our last session of the webinar. Today, my name is Carlos Klapp. I'll be the one conducting your webinar today. We'll start in 1 more minute, and while we're waiting for everyone to get back from the break, again, the webinar is being recorded. You will get the slides, the recording, and all of the SQL snippets and code. They'll be put up in our GitHub. And also, someone mentioned contributing things to Data Virtuality and through GitHub. And we're very interested in that. We were wondering about that in our community, if there was interest in that. And we would like to hear from you and know what it is you would like to contribute and discuss that. So please reach out to us. So it is now time. Hope everyone made it back. And I'm going to begin the presentation now. Our topic today is going to be advanced SQL problems and solutions. And again, please, at any moment, please ask your questions. Some of these topics that we're going to be looking at are somewhat more abstract. And so please, if at any point the explanation was not adequate, please post your questions and I'll do my best to answer them. Today we're going to be looking at a wide variety of topics and problems. And again, all of the code used in the presentation will be in Data Virtuality's GitHub account. The first thing we're going to look at is something called a tally table or a numbers table. The concept is very straightforward, and we're going to look at what it is and how we use it. And then we're going to begin looking at the applications later on in this session. So the numbers table is actually a very simple concept. It is just the table that contains one single column, and it is all of the sequential numbers in our particular case from 1 to 1 million. And the reason we make it, you can make your own numbers table much smaller. I found that 1 million covers pretty much every single possible combination of scenarios, including what's the number of days from here until 9,999. It's definitely less than 1 million. But we'll see in a minute why you want a pretty big numbers table. You can, and in the past, I've split up the numbers table to a small one, less than 1,000, and really large ones around 1 million. So the first thing that we're going to do is, in order to initialize this and to create our numbers table, inside the schema that we provide for you is going to be called the Masterclass 2021 Advanced SQL. So you're going to call the stored procedure init the numbers table. And this is going to create a table in your analytical storage called numbers. And again, very simple concept. It's just long. The data type is long. So if you run into any complaints about from Data Virtuality about long and conversion to integer, just do a cast. And we'll see a couple of examples of that later in the code. Like I said, it's just a sequential number, sequential series of numbers from 1 to 1 million. And here also inside, one of the important aspects of having a numbers table is to make sure you add your primary key. And in the particular case of, for my scenario, you'll see the code that I've included includes an alter table with a schema of DWH, Data Virtuality 245, which is the latest version I'm using, and it will add the primary key. And the reason you're going to see the DWH DB245 is because, that is the name of my schema. So if you see this, please change it to your schema and to the name of your numbers table. And that will go through and create your your numbers table. Open up here, and we'll take a quick look at what it actually does. So all it's doing is it assumes that you do not have a numbers table. We only need to create it once. And we'll go through and just do a row number. And it is going to do a Cartesian join, where it's going to select 1,000 rows from our columns table twice. And because we're doing Cartesian join, that results in 1 million rows. And again, we talked about using options and features of data virtuality. And in particular, we try to protect people against accidental typos where there's a Cartesian join by accident. So here we have to specifically write the option allow Cartesian joins, right? So this will allow us to build a numbers table with 1 million rows, and then we're just going to add the primary key to it. So now we're actually going to start getting into the interesting things. So previously we looked at the date access function where we looped through the values. We had a start date and an end date, and we looped through them. So another possibility, we're going to be using that function too, but another possibility is for us to use the numbers table. Like Matthias mentioned before, it's not necessary to use the numbers table. Simple for loop will work just fine. But we're going to begin looking at how you can analyze and structure different things and what you can do with a numbers table. So to begin with, what we want as a result is 5 dates starting today, and we want the next 5 dates. So June 2nd, 3rd, 4th, and 5th, and 6th, right? So what we're going to pass into our date access function is our start date and the number of days. And what we're going to do here is return the first 5 days, right, from our numbers table, right? Values, rows 1, 2, 3, 4, and 5. And since we want it to start with today, we don't want to modify the start date. So what we want to do is our initial start date, since we want it to remain June 2nd, we have to subtract 1 from it, right? So we're querying the first 5 days, and you can see here in our select statement that we're subtracting 1 from it. And this is what we want, right? So we want to add 0 for the first value, and that will leave it as June 2nd. And then for the second row in the result set, we're going to add 1 to it. And that's going to return June 3rd. And for the final row, it will be a 4. So we're going to add 4 to our start date, and that is going to give us June 6th. So again, a different method of performing the same thing that Matthias had presented previously. And again, you don't need to use a numbers table, but this is kind of an introduction into the concepts. And again, if at any point it isn't clear why we're doing something, please send me a question, and I'll do my best to answer it. So this is kind of a brief into and some of the application of using number tables with dates. The next thing we're going to look at is how we can use a numbers table with text. And again, here our goal is to take a string and split it out 1 single character per row. So we're taking Data Virtuality, and we're taking the first character, second character, 5th character, all the way to the 15th character. And so what we're going to do here is the first part of our query is that we're going to select the numbers from 1 to 15, 15 being the length of the string Data Virtuality. So we're selecting the numbers 1 through 15. And then we're passing that into, we're using that as part of our split text. So we're passing in our string, which is Data Virtuality. It's 15 characters long. So we're going to select the numbers 1 through 15 from our numbers table. And we're going to use the value in our numbers table, which is 1, 2, 3, all the way to 15, as our index into substring. So what we're doing is we're saying take the string data virtuality and grab the first character and only grab one character in length. And then that'll give us the D. Then grab the second, right? We're going to get the number 2 and grab the second character, which is going to be an A. And this is going to move us all the way down to the 15th character being the Y. So again, we can do this with simple looping. But the reason I want to do this is I want to also, most people would tackle this problem or solve this problem using a simple loop. And I want to begin presenting the use of tables and a numbers table and get you thinking a little bit differently about how you parse and analyze data. And this is going to become more useful a little bit further down the line when we begin analyzing sequences of data for gaps and overlaps in data. Again, at any point, if you have any questions, please post them. So the next thing is we're going to start looking at the application of this, and we're going to begin looking at a series or a sequence of data ordered by time or by number, and we're going to begin looking for gaps in the data sequence or overlapping segments. So again, the first thing we're going to do is we're going to initialize our demo data. We're going to call our Masterclass 2021 Advanced SQL, and we're going to call init invoices. Let's take a look at that quickly. All we're doing here is creating table invoices and dropping the table if it exists in our analytical storage. And then I wish I'd watched Matthias's presentation on the utils schema, and I would have used the utils create table start procedure there. Instead, what I did was I specified the create table as a string and then executed this as dynamic SQL. Again, both methods are valid. But again, if I had to go back and re-implement it, I would have used the utils function. And now we're just going to insert the values into our invoices. Right? So we're just inserting an invoice number, a license start date, and a license end. Very simple, just creates it once. All you need to do is run it once. And now we'll have our sample data. And now let's take a look at our sample data. So we have a, so if we run a select statement for our invoices, we're going to notice we have 6 rows. The invoices, the invoice numbers have a gap, right? 1, 2, 3, and we're missing 4 and 5, and then 6, 7, 8. And if you look, this particular, these are the rows that, conceptually would correspond to a particular client. And they bought a license that extends, their first invoice was from June 1st to July 1st. And then they bought another license that ran from July 1st to July 31st. And as you can see here, we have an overlap in July. So for August, it was fine, August 1st to August 31st, perfectly good, perfectly fine. There's no overlap. Then there's a gap here from September 1st to September 15th. And there's a 16-day gap between October 1st and October 31st. And then we have another overlap. This particular client purchased a license and their license overlaps by 16 days here from October 15th to November 30th. So this is the data we're going to begin looking at. And the things that we're interested in is we're going to look at the number of invoices, and we're going to begin trying to find gaps in our data. Then we're going to be looking at our license start and end dates. And we want to find any overlaps, and we want to find gaps in this data. So let's begin looking at what we're trying to accomplish here. So one of the functions that we have in Data Virtuality is the accept and intersect. The accept, if you remember your Venn diagrams, it's subtracting one data set from another. So what we're going to do here is, in these examples, there have been hard-coded. So we know that there's 8 invoices. So we're selecting from our numbers table the values between 1 and 8, and we're subtracting the invoice number, our invoice number, from this set. So what this will give us is then the values 4 and 5, which are the missing invoice numbers. So again, this is a very simplified version of why you want to begin thinking in auxiliary tables, such as a numbers table, and how you can apply it and how you can use the different functionality such as accept. The accept statement is widely supported in databases and is typically much faster than doing a left join. So this is one of the reasons I want to bring it up. It's not as common not as commonly used as a left join. So I want to begin getting people thinking about different techniques and different ways to think about their data and how they're going to begin processing. So right now, what we've looked at, what we have accomplished is looking at a sequential series of data and how we can find that gap in that data. So the next one we're going to look at is slightly more complex. Most information has a start and end date for licenses, periods, various things. And we want to be able to begin looking at this and thinking about this in a slightly different way. A lot of this could be analyzed simply by finding overlaps. We could do a join here and say if there is at any point a value that overlaps with the end date, then we know there's an overlap. But in this particular solution, we can do it. It's definitely the more efficient way of doing it, is definitely using a little bit of logic to find the overlap. But we also want to be able to think about structuring things slightly differently. We want to begin analyzing things by combining them with auxiliary tables and actually pointing out the data, structuring it differently, right? So what we're going to begin doing here is what we talked about in the previous slide. We're going to take our start date and our end date, and actually we'll want to like break these out for every value that corresponds to June 1st to July 1st. We want a row for that. We want one single row. So here on our license end date, right, what we want the result to be is our invoice number, right? And we want, this would extend all the way from June 1st all the way to June 30th. And again to July 1st, because that is our end date here. And then for invoice 2, we want all the values from July 1st right here, all the way down to July 31st. And the way we're going to accomplish this is we're going to look at the date axis that Matthias had presented in the previous slide, right? We take a start date, we have an end date, and then we're going to just loop over all of those and return one single day for each of those values. And in this particular example, I've hard-coded the values to make it easier to understand. In production, you would grab the minimum and maximum values for your start date and end date, and then simply build out all the dates for that. But again, we want to make it simple, right? Easy to correlate, easy to figure out what we're doing. So I've hard-coded the values July 1st to November 30th, which correspond to our start date here and our end date here. And then we're going to join this back to our invoices. And we're going to say for every invoice, right, take our X date, right, which is just these, and join it whenever it's between the license start and the license end date. And this will give us this data set. So again, when you're doing these joins and you're using temporal data or sequential data, begin thinking about how your start end date fits or can be joined by using your between statement, right? We're very used to doing joins where we would say less than, equal to, but begin thinking about like how to use it between, right? Because that's really what we're trying to do in a lot of this analysis with sequential data and temporal data, is we're trying to look at how this fits together in a range, right? So begin thinking about how you analyze this and how you process this mentally as a range of data, right? So now what we've built here is using this, this view, is that we now have a sequence of data, right? For every range, right, from our start to end date, we have one single row that corresponds. And this is going to make it easier for us to perform the analysis in the next step. Again, at any point, if something needs further clarification, please let me know and post a question. So the next thing we're going to look at is how to find our gap in our date range. So again, let's look at our invoice data, right? Same as before. And we're going to begin using our end date. We're going to look at we're going to take all of our dates from our start date, which is June 1st, which is our earliest start date, to our last start date, which is November 30th. Right? We're going to take this, and we're going to use the accept. So it builds this data set, all of our dates, and then subtracts all of the dates that we built from the previous example, right? And this is going to give us the dates where there are gaps. It's going to give us a series of gaps. And what we're looking at is from September 16th to September 30th, we have a gap in our licensing here, right? So this particular customer was not covered by this, by a policy, by a license, right? So we're talking right now about invoices, but another application is if you have any kind of temporal data, you can begin analyzing this, such as visits to your website, right? How often, how many consecutive days did the user come, right? Were there any gaps in their visits? How long what was the largest gap? What was the smallest gap, right? What was the longest number of consecutive days that they came, right? So if you begin correlating this to articles and pages and the consecutive days, you might be able to find some more insights into your data, right? For ease of comprehension, we're using this made-up table of invoices, but begin thinking about your temporal data, right? Your web visits, right? Licensing, start, and anything, anywhere you have a start and end date. Begin thinking about that and how you can apply it. And if you have any applications that come to mind and you would like me to like elaborate or give a comment on them, please post your questions. So now we've completed this, we've completed finding a gap in our date range. So we're going to move on to the next step, right? We're going to look at overlapping dates. It would be easy to find the overlapping dates. Again, let me go back really quickly. Again, it's easy to find our overlapping dates. We just need to look at our start date and the end date, right? And see if any of these overlap, right? We could just use a less than. But and that would be much faster. But the purpose now is we want to begin thinking about how to expand our data and how to begin combining it with other things. So one of the things we're going to look at now is finding the overlapping dates using an expanded range of dates, right? And one of the features that we're going to look at is common table expressions. You can see that we use here in our next view, we're using a common table expressions. Please post in the chat how many of you are familiar with common table expressions or are using them now. Common table expressions are pretty simple to grasp, and a lot of times they're very fast. And the majority of databases now support common table expressions, so they can be pushed down to the data source. And essentially what a common table expression is, or you can think about it as being a temporary table. Right? We don't have to actually explicitly create a temporary table. Most of these common table expressions are created in memory in a lot of databases, and they only last the duration of the query. So they're very fast, they're very efficient, and a lot of times they're just easier to write. What we're doing here is we're saying, okay, create a common table expression called, I use CTE for common table expression, all of our dates, right? So think of this as a temporary table. And again, this is the same logic as we used before, right? We're gathering our invoice number, state, start date, end date, and a row for every date in this time series. And then we're going to define a second common table expression known as duplicate dates, right? This one here, we're leveraging the first common table expression. Think of it as a temporary table. We're leveraging our first data set, right? All of our dates here that we defined. And we're selecting only the date part, right? And we're grouping the date, and we're filtering these by saying we want all of the dates that occur more than once, right? Because if we have overlapping dates, what we're saying is that they're going to occur more than once we just look at the date portion. So now we have all of the dates that overlap, or and we found these by counting them and making sure that they occur more than once. And we want the original information too. We want the invoice number and the start and end date. And the way we're going to look at this is we're going to join our duplicate dates and all dates back together again. And we're going to join these on our X date. Okay? So again, think of these as a temporary table. We're building all of our dates. We're using all of our dates again to find the duplicate dates, and then we're joining these back together. And this is the result set that it's going to give, right? For invoice number 1, we have an overlap on July 1st. And if we look here, this corresponds to the second invoice, which started on July 1st, right? And we have also another several more days where it overlaps in October and November. Again, this could have been done with very straightforward logic, just looking at the values between the start and end date. But again, the purpose of this is to begin thinking about temporal data, right? Thinking about how data changes and happens over time. And we're using the X date, right? Our extra date column here. This is going to represent our temporal table. So originally we thought of our table as just being an invoice number and a license start date, but begin thinking about this as the primary column being our X date, right? And our X date each date has one or more pieces of data tied to it, which can be the license end, the license start, and the invoice number, right? So this is a way of changing how we look and how we interpret our data. Right? So we're no longer focused on our invoice start and end date. We're focused on our dates. Right? And dates can now have multiple pieces of information. Again, if you have any questions, please post them. And it looks like I'm missing 1 second. My chat has been, my little chat window disappeared. Here we go. There we go. Yeah, just my chat window was hidden, so it looks like quite a few of you are familiar with common table expressions. That's great. Uh, so now we're going to look at, we found the overlapping days. Now we're going to look at the number of max consecutive days, right? And our goal is we want a very simple view that we're going to look at. And we want to find how many consecutive days did this client have coverage for, right? And we want to group these. So, and the result we want is for our first data set, right, to show how many days. And based on this, it was 107 consecutive days of continuous licensing. There was a gap, and then there were 61 days of continuous licensing, right? And this is represented by two groups. The first group, it has a value of 0, and the second group has a value, begins with a value of 15, right? And these are arbitrary grouping values. And we'll see where these come from in just a minute. So again, let's look at our original data here. And we're going to do the same thing, right? We're going to look at our license dates, right? And again, begin considering this and looking at this from our X date perspective, as if this were our primary, well, it's not a primary key because it has duplicate values, but think of this as being our index, our primary goal. So once we've selected X date from our license dates, we're going to have all our consecutive dates, and we want the distinct values. When we're looking at grouping dates, we only want the distinct values. We don't want to see any duplicate values or throw off the algorithm. So the first thing we're going to use is, again, our common table expressions. Our first common table expression is distinct dates. We get all of our distinct dates. And it's going to correspond to this column right here. The second thing we're going to do is we're going to use our distinct dates, and we're going to add a row number, right? And we're going to order by our X date. So this is going to give us these two columns right here, our X date and the sequential order in which they appear. So the next thing we're going to do is we're going to join our numbered distinct dates. That should be numbered, a little typo there, our numbered distinct dates, and we're going to join it back to itself, right? And we're going to join table 1 with row number and to the second distinct dates with a row number +1. So if we look here, right, this is our first data set, and here's our second data set. So C1, our alias C1 here, our row number 1 is being joined to the second C2, and these are our row numbers right here. And the interesting thing here is if the C2 X date, right, this column right here, is null, then we're going to say our the difference between this date and the previous date is 1. We're going to use this for the algorithm. And the other, if that is not the case, we're going to subtract the current date, which is this column, from our previous date, which is over here. Excuse me. Sorry, other way around. We're going to subtract our current date, which is June 2nd, from our previous date, and it's going to give us a difference of 1 day. And again, we're going to follow this logic all the way down. And you can see here that suddenly we have a value that is not 1. So when we subtract our current date, which is October 1st, from September 15th, it's actually going to give us a difference of 16. So if you begin looking at the sequence, you can begin seeing a pattern, right? And we're going to use this pattern in order to find and group our data into islands of consecutive data. So we'll look at this in the next step here. So this code got a lot more complicated, right? So it's the same code as before. It looks a lot more complicated, I should say. Same thing again. We're taking our distinct dates, right? We're putting a row number to them. We're joining the distinct dates back onto itself, right? Which gives us this row joined to this row, which gives us these two. And again, the same logic as before. We're taking the difference, subtracting the previous date from the current date, right? And this is going to give us a difference of 1 all the way down until we have a gap in our licensing.
Carlos, one second. Can you elaborate on that? Because you say it's current date and previous date, but you did not create them by just subtracting one, right? It's coming from the data because the difference is always 1 and then suddenly 16. Where is that coming from?
Yes. Because we're joining our distinct numbered distinct dates is the date and the row number, and we're joining this on the row number and the row number plus 1. So this gives us this column, right?
Okay, I understand. Thank you.
Oh, thank you. That's a great question. And then we're just subtracting these two values right here, the X date, the current and the previous value right here. And we get the value of 16 because we're subtracting October 1st and we're subtracting September 15th. And this gives us a difference of 16 days. Right? So the next step we're going to do is build another common table expression. Right? We want the same rows as before. And now one of the things we're going to use is a windowed function. And we're going to use the sum. And what we're saying is order by the current row. And we want all of the preceding rows. So we're doing a cumulative sum from this row upward, and then from this row upward. So this gives us a cumulative sum. This is one row. Previous state is 1. So now we have 2 rows, and we're summing the 1 twice. This gives us a cumulative sum of 2. And as you can begin seeing, we're progressing down, right? It's a cumulative sum all the way down. So it suddenly gets really interesting. So if you begin noticing that this row number and this cumulative sum are matching, right? And we're going to use this pattern here to group our data, right? So now we have a cumulative, when we get to September 15th, right? You know, we still have a difference of 1 day, and it gives us a cumulative sum of 107, right? And this corresponds to the number of rows. We have 107 rows. Right? So suddenly, when we get to October 1st, right, and our previous date was September, we have a difference of 16, right? So now suddenly, our cumulative sum, instead of being 108, jumped to 123. Right? So this is where we start using this pattern to begin grouping our data, right? So now what we're going to do is take this sum, this cumulative sum of all the previous rows, and we're going to subtract out the current row, right? So previously, all of these had resulted in 0, right? The cumulative sum corresponds to our current row number, right? And it gives us a 0. So now suddenly we have a value of 16, right? So when we subtract 123 and we subtract 108, it gives us 15. And because we're using the cumulative sum, right? We have 123 for our cumulative sum now. In the next row, there's a difference of 1 day. It gives 124, and we subtract 109 from it. It still gives us a difference of 15. So now we can use this difference between our cumulative sum and our row number to actually group the data, right? And this is our first grouping of data, right? Group 0, and our next one is going to be group 15. These values don't really matter much. The only thing important is that they're changing. And if we had another gap in our data sequence, we would have another number here, right? So this would give us a way to number and easily find the grouping of data of consecutive data. And so let's proceed a little bit further. So now what we can do is, because we have these groups, right, based on our cumulative sum, now we can begin doing a count, right, based on our group. So on group 0, which was our first set of consecutive values, we have 107 consecutive values. In our second one, which had a value of 15, had 61 consecutive days. So again, we're using a fictitious set of data made up of invoices with a start and date, but this could just as easily be used for users visiting your website. Again, the goal here is to begin thinking about your temporal data slightly differently.
Can you share, Carlos, can you tell us a little bit again, elaborate more on the meaning of this data? So in the first row, that was basically 107 consecutive days the user was visiting, and then there was a break, and then there was another chain of visits, right? Is that correct?
Yes, yes. In this particular example, we're using our invoice data. So it's licensing, but it can just as easily be visits to your website. So the important thing here is that we have a consecutive series of dates, and we have a gap here, right? We have a 16-day gap. And we're using the relationship between our row number, the difference between this date and the previous row, right? And we can see here that our gap is 16 days. And we use the relationship here of the cumulative sum, right? Because we're doing the cumulative sum and these are ordered by our date. The row number should correspond to the cumulative sum. So now we're subtracting our row number from our cumulative sum, and this is going to give us our grouping. It's a little hard to kind of get your head around the first time. But basically what we're doing is we're ordering the dates, and we're using the position of our dates ordered sequentially, right? And we're using the relationship of the previous row, right? Because we're joining these here, right? This is the previous row, which is row 1, right? And we're using this relationship. And as we can see here, when there's this gap, the previous row is row number 107, and it's September 15th, right? And it's this row right here.
Mm-hmm.
So we're looking at the previous, looking at the relationship between the current row, which is October 1st, and the previous row. Right? And we're using this difference in the dates between the current date and the previous date to get our difference, our date difference, right? And we're using the cumulative sum, right? If there's no gaps in our data, the cumulative sum is always going to correspond to our current row number. But because there's a gap in this difference and we're using the cumulative sum, right? 107 plus 16 gives us 123. So when we subtract our current row, which is this one, this part of the query right here, now it gives us 15. Because we're using the cumulative sum, we're always adding these values. So this next group of data is always going to have the value 15.
Got it.
And
Thank
if we had a third set of data, it would have a different number, and that would be based on the number of days that this gap is. And the actual value 0 and 15 don't really mean anything. They're kind of meaningless in this particular sense. You know, we just want different values for these groupings. And once we have them, then we can just use simple group and account to find the maximum number of consecutive days. The logic, again, of course, could be reversed, right? We could look at the number of consecutive days that there's a gap in licensing, you know, for this data, this example data set, or a gap in visits that a customer has not visited our website. So that concludes this section of kind of an introduction to finding gaps and islands of data. We're quickly running out of time. So this is, which is great because we're coming up to the end of the presentation. One of the things that has happened, and we get a lot of comments about customers from, is how do we detect changed records? Ideally, when we have changed records in a table, we're going to have a modified date. This is the ideal situation, right? It makes it really simple to do updates, to do an upsert. If the ID doesn't exist in our destination table, we know it's new. If the ID exists, but the modified date has changed, then we know we need to update it. But a lot of customers have this scenario, right? For one reason or another, there's no modified date. What can we do? The fastest way to usually handle this, and if this is possible, and is to add, well, when we go back, is to simply add the modified date. If that's possible with your data, add the modified date, make the modifications to your system, and just handle it that way. If that's not feasible, the other thing that we recommend is on your source system to create a trigger, right? So you cannot, one of the rules here is it would break the system if you added another column. So you can't do that, but you can add a trigger, and then you're going to add a companion table, which would have the same name, and it would have maybe appended with modified date. And the only thing you're going to need here is your ID and your modified date. And then when you're doing your upsert, you can just join these two tables. And again, we have your ID, your columns, and your modified date, and makes it very easy to perform your updates. But what happens if it's not feasible to add a trigger? We can do a couple different things. We can create a hash of the values. Again, I'm not going to go into a full solution. It's just something to think about. We're going to use an MD5. You should not use MD5 for security because it's too small. It can be easily cracked. But for creating hashes that are really fast and capture the uniqueness of your data, MD5 is usually going to be just fine. You're not going to really run into any problems. If you feel more comfortable, you can use some of the longer hashes now, like SHA-128. But MD5, I found, is usually really good.
And
So
if I may add
yes.
something here, that MD5 is pushed down to most of our data sources. That also increases the speed of operation here.
Thank you. Good point. That's great. That's a great point. And what we're going to do is, because we want this to be fast, right? What we're going to do is we're going to use MD5, and we're going to add some sort of separator. And the reason we add some unique garbage separator is if you used a period and it's text, periods occur very frequently in text, so that's not really what we want. We want something that's pretty unique, right? So we're going to just use this that's just kind of gibberish, right? And we're going to concatenate columns 1 and 2, and we're going to build the hash off of this, right? So these are the original hashes. So here in the second view, I have V2, right? And it's this data right here. A, B, and C have not been changed, same row IDs. And column 2, these have been changed. And as you can see here, row 3 has not changed, so our hash is the same, but the hashes for the first 2 are different. So we don't have a modified date, but now we have an indicator of what rows have changed. So we can use this hash key to select the values that have changed by comparing the values in the source system and the target system, right? So again, this is not a full-scale implementation. Again, a conceptual solution to these types of problems. The next thing we're going to look at is dynamically creating stored procedures. One of the things here we get a lot about is we want to be able to alter these stored procedures dynamically when we want to go back and change them. It's not enough just to recreate the stored procedure, drop it. We sometimes want to just alter the stored procedure. So there's an example in our schema. It's just called a stored procedure, replacing text. And I've seen a lot of, it's very common to see people build dynamic SQL and using it what is termed an additive method, right? You would say, create procedure, concatenate the procedure name, concatenate the rest of this text, then concatenate. And you'll see if statements and I've seen code where it's pages and pages of if statements and concatenation, and it gets a little hard to follow. And I really recommend more of a replacement, right? So, for example, we're using the less than, double less than, and double greater than, and to delimit the text, the variable. As we can see here, we have the proc name, and we have element columns and metric columns. And simply we take this text right here and we do a replacement, right? Makes it a lot easier to follow. In majority of cases, it works great. And we're going to also look at what Matthias talked about, using regular expressions to replace different parts of the text, right? We'll just kind of jump into it. We don't have enough time to go into full implementation, but we'll kind of touch on it. So here, if we call the stored procedure, right, we're going to specify our procedure name as dummy sproc. Our metric is string metrics and string elements, right? And what this is going to go through is replace the text here. And here I obscured a call to execute the SQL code, and this will actually create the dummy sproc, right? And you can see here that this is the new name, and that we have string elements as a string and string metrics, and again, this is a dummy sproc. Again, we're going to go back to dynamically generated stored procedures. But first, let's begin looking at some of the embedded languages that we support, right? We already have the regex replace that has been implemented natively. I recommend using that. But again, one of the things I want to touch on is Matthias has already elaborated on this quite a bit. One of the things that I wanted to talk about is how it works, right? We specify using object table in our language. This is actually a single string here, which is the code in JavaScript, right? And the passing keyword here is telling it that we're passing the next 3 rows as parameters, right? Our initial string, regex, and replacement. And what it's returning is a single column, right? Is our single column in DB row, and it's returning that string that has been had the replacement text, right? And again, we're going to put this all together in the next section, right? And again, here we looked at this previously with Matthias. You don't always have to call your stored procedures inside your from statement. You can use these as functions within your select column. Right? And again, we talked about this before, and we talked about how you can embed these, right? So here's another example of doing a cross join, right, with a JavaScript function defined in the same thing. We don't have to dedicate a stored procedure to defining a particular function, right? We can do it completely in line. And again, Matthias talked about this one before, but let's look a little bit at JavaScript and what it's doing, right? Here we're defining an array called rows, and we're defining a JSON object, right? Key value pairs, and we're pushing this into as the first row. Then again, we're defining a dictionary, right? Column 2 and the value is foo, column 3 is bar, and we're pushing this into a row. We're appending this to the variable rows. And then what we're doing at the end is we're getting column 1, 2, and 3, and we're looking at this result set, right? And we're parsing this out, because the last thing that is here in the JavaScript is what's going to be returned as DB row. Right? Okay, so let's begin putting this together. Okay, we looked at a little bit about the regex replace. We looked a little bit at how we define regular expressions in other language and can call in other libraries. So let's begin putting this together with some regular expressions, right? Wikipedia has a good article on it. It's a bit technical. Basically, the thing that for regular expressions is we're looking for patterns, right? So this is an example of a great pattern, right? We're looking at two or more spaces if they are after a period and before an uppercase letter, right? So we're looking at this text. This is an example of a regular expression pattern. A great book on the topic. We don't have enough time to really dive into regular expressions. Great book on the topic. We're not getting any money from this, so this is just a good reference material. And also another good one for tutorials and learning is regex1.com. So some of the things that we're going to begin talking about a little bit is it allows you to, regex1 allows you to interactively look at your data, right? So here, dot, we look over here, a dot means any character. And we can look over here, the star after it means 0 more repetition. So what we're saying is find any character that repeats 0 more times, and that will match all of these strings. So again, this is not a full-blown session on regular expressions, kind of a little bit of a superficial dive into it. And say, for instance, we want to match just the first 3, right? So we also have a grouping, a capture group, which is the parentheses. And we have the pipe, which isn't explained here, but the pipe functions as an OR. So we're saying find the letter C or M or F, and then followed by the letters AN, right? So it matches the first 3. So again, this is kind of a brief introduction into the concepts and how you can begin to apply. So let's bring this together and wrap this back up, right? So we can get the procedure definitions from our system tables. We'll quickly look at that. Sysadmin. So we can look here at our procedure definitions table. And if we look at this, the column we're interested in is this one right here, which is called definition. This column right here actually is the entire definition when we created the stored procedure, right? And it always starts, if you notice, with a create. Even if you just issued an alter, it's still stored as a create. So if we want to go modify this dynamically, we need to replace this. And we run into problems. We can't just grab the first 6 letters, you know, and assume it's a create, because sometimes, depending on the version of Data Virtuality, it might have a leading space or a leading new line character or a line feed. So what we're going to do is we're going to do a couple of things, right? We're going to use regex 101, great website, and it actually tells you what each one is doing, right? So the thing here that we're going to use is the ampersand. This tells it at the beginning of the text. And this is important because inside of our stored procedure, we could use the word create again, right? We could use the word to create table, or we could have comments in there that said we will create a temporary table to do this. So we don't want to like change all of the creates. We just want the first one, right? And because we can have multiple spaces here, right? We're saying /s. /s matches any white space character. And we want the asterisk, what we looked at previously, right? Which we have here. And this matches to 0 or more repetitions. So we're saying if there's any, at the beginning of the text, if there's any white space, right? 0 more matches to white space, match that. Then match the word create and a space. Right? So this is one we want to replace. So how are we going to do this, right? So we have a stored procedure in our samples, how to alter a stored procedure, right? We get the definition of the stored procedure for our dummy sprock that we created previously, right? We get its definition because we're getting the column called definition. we're going to pass this into our regular expression replace. And we're passing in the definition, which is this text right here. And we want to get this back right here. So we're passing in the regular expression that we just looked at, right? The beginning of the text, some white space, and the word create in a space. And we're going to change this to an alter. Right? So this is kind of like laying the foundation of how you can begin to dynamically, not only dynamically create SQL, but begin to dynamically alter your SQL. Okay. So now we're going to get a little bit more into the regular expressions, right? We have to use a backslash here because we're trying to match the comment, which is /*, right? But the slash is already a reserved character. So we need to use the backslash in order to escape it. So the first two characters, the backslash and slash, are going to match this first slash. And the asterisk, right, is also predefined. So we need another backslash to escape it, excuse me. And so we're doing backslash asterisk. So this is going to match our first asterisk. And then we're going to say, once we found our first comment, match any character any number of times, right? Which would be here. And then we're going to define our end comment, which is backslash asterisk, and then backslash slash, right? So we have now defined a regular expression to match comments, but we have a problem, right? We have 2 lines of comments here, right? And it matched everything. So what we're going to do is we're going to use the question mark, and the question mark after the asterisk here says it's going to be non-greedy, right? So the previous example is what's called greedy. It matched everything from the first one all the way to the second one, which is not what we wanted. We just want to match a single comment, right? So we add the question mark and we make it non-greedy, which matches the first one it encounters. And now it actually has 2 matches. So if we look at our SQL window here, you can see we're using regex 101. And it says it found 1 match, characters 239 to characters 299, and then characters 305 to characters 365 right here. Right? And again, the nice thing about regex 101, it gives you a nice explanation of what it's matching, right? And now we have, we have the foundations to begin altering our stored procedures, right? Altering anything we want inside of our table. And so now we have something interesting, right? We found a 2 comments, right? So we're not limited to just comments. We can actually put in tags within our comments saying this is the beginning of a comment, the start tag, and then use the second one as an end tag, and begin deleting entire sections inside the stored procedure or inside text. And you can begin to dynamically alter and modify all of your stored procedures. This is really applicable if you have a large number of stored procedures and you're trying to migrate to a different schema or a different scenario. This comes in really handy, right? Because you don't want to have to recreate all of these, export these, do them by hand, and then recreate them and set up permissions all over again. You can begin to use regular expressions to retrieve the definition of your stored procedures and modify them dynamically. And also, we're going to look at this later on. We're going to look at this tomorrow. We're going to begin looking at data, metadata, and permissions. So in theory, if you queried your source database using native functions to get your permissions, you could then begin to import your permissions and apply them by parsing these using regular expressions and just normal SQL, and begin to import your permissions from your source systems and apply those to the stored procedures and views that are inside of Data Virtuality. Right? So again, a couple of clients have talked about that, and they mentioned that they have a lot of their infrastructure already built in their data source systems, and they would like to import their permissions. So these are some of the building blocks that you could use to begin building this infrastructure out. And again, hopefully in the next masterclass, we'll build on this particular webinar and begin looking at how to alter these and begin importing different permissions and looking at different techniques that we could apply. So these are some of the more advanced SQL concepts and some of the more advanced solutions that you can use SQL to solve.